Before we really get into the coursework for the semester, I wanted to take some time to emphasize or re-emphasize the importance of basic algebra skills in this course. It's not unusual for me to have heard from a former calculus student statements like, "I find that algebra is harder for me than the calculus." If it's been a long time since you studied the algebra, or if you just felt like you never got a really good grounded in your basic algebra, that statement may actually be true for you. And this is the time to help take care of that and to remedy that situation. Having algebra skills that you feel are not up to where they should be is not necessarily going to mean that you can't do well in this course, but it does mean that it's something that you have to be proactive about and get under control before you get deep into this course. What I'm going to do here is to follow up with some examples. They're not very in-depth and they're not necessarily the breadth of everything that you'll need, but just give you some idea of the sorts of really very basic algebra skills that can trip you up during this calculus course if you don't get them under control. So take this very seriously. It's not something you can just blow off. Toward the end of the semester, mid-semester, maybe even quarter semester, you may have waited too late and negatively affected your course grade before you ever realized that you should have taken this seriously early in the course. So my encouragement here is to get this under control early, take it seriously, focus on it very early in this course, and get a handle on it. So having said that, let's just dive in. These examples are not that in-depth and they're not necessarily the breadth of things, but it gives you some idea of what I'm talking about here. So start off with this one. What if I ask you to write the following expression without negative exponents? And the first one is 4 to the negative 1. Now you have to remember that a negative exponent means it's the reciprocal of the positive value. So 4 to the negative 1 is the same as 1 over 4 to the positive 1, and of course 4 to the positive 1 is just 4. Simple, but you have to have that skill. What if I give you something like this? 1 over 4 to the negative 1. And the simple way to do this is to think of a fraction as top, bottom, and if you've got a negative exponent on a factor in the denominator, if you switch it to the numerator, it changes the sign of the exponent. And vice versa, if it were in the numerator and you switched it to the denominator, it would change the sign of the exponent. So what you realize is 1 over 4 to the negative 1 is the same as pushing the 4 up to the numerator, changing the sign negative 1 to positive 1. So you end up with 4 to the 1. This should become second nature to you. You shouldn't have to take 5 minutes worth of writing things down and figuring things out to get that. This should be something that just comes right to your mind because you've done this in the past and you need to get your skill level so that your algebra is not slowing you down so much that you can't focus on the calculus later on. And of course, 4 to the 1 is just 4. How about this one? If you've got a fraction raised to a negative exponent, it's like switching the numerator and denominator to change the sign. So 1/4 to the negative 1 is flipping the fraction is 4 over 1 to the positive 1, which of course is just 4. The algebra is not difficult, but it's the kind of little thing that's going to be embedded into calculus problems throughout the semester. And if you're focusing on how to do the algebra so much you can't focus on the calculus, this is going to have a negative impact on you. 4 to the negative 3. That's sort of like A, 4 to the negative 1. 4 to the negative 1 is 1 over 4 to the 1, so 4 to the negative 3 is 1 over 4 to the third. And 4 to the third is 4 times 4 times 4, which happens to be 64, so the answer is 1/64. 1 over 4 to the minus 3. Well, as I said back in B, if you push a factor with a negative exponent from numerator to denominator or vice versa, it changes the sign of the exponent. So 1 over 4 to the minus 3 is 4 to the positive 3. Over 1, if you want to think of that as over 1, but over 1 just means 4 to the third, and 4 to the third, of course, is 64. 1/4 to the negative 3, very similar to the C problem. You flip the fraction, 1/4 becomes 4 over 1, and the minus 3 changes to a 3. and you get 4 over 1 to the 3, which is just 4 to the third, which is 4 times 4 times 4, which is 64. So if there's any part of this that you don't just see immediately how to get an answer to this is something you should focus on, because those little things are going to cause you pause as you're doing your calculus problems, and you'll either make a mistake or it slows you down enough that you don't have time to focus on the calculus as much as you should. So make sure you take care of this if you have a deficiency. Let's continue. It says write the following expressions without negative exponents. A says 4x to the minus 1. Well, again, a negative exponent on a factor indicates that if you change its position relative to think of it as a fraction, top, bottom, it changes the sign of the exponent. So if you think of 4x to the minus 1 as having an understood 1 in the denominator, then if you push that x to the minus 1 down into the denominator, it becomes 4x to the positive 1, which of course tells you that you just get 4 over x. B, very similar to A, but notice that the parentheses is a clue that the order of operations are being changed. In A, powers come before multiplication, so you want to raise the x to the minus 1 before you multiply it by 4. That means the 4 is not affected by the negative exponent. But in this problem, both the 4 and the x are in the base of the expression that has a negative exponent, so they're both affected by that negative exponent. So when you push the exponent down, the 4 and the x go with it. So you get 1 over 4x quantity to the 1. Of course, 4x quantity to the 1 is just 4x. You have to see the difference between A and B. Very subtle difference, but it's going to cause you to miss a problem if you don't distinguish. C is very similar to A. The minus 2 is not part of the exponential expression. So the x is to the negative 3. The minus 2 is not part of that. So the minus 2 doesn't move. The x to the minus 3 changes to an x to the positive 3 as you push it into the denominator. As opposed to D, where the parentheses changes the order of operations, and now it says the minus 2 is stuck with the x, and it's part of the exponentiation. So now when you change the minus 3 to a positive 3 by pushing it down, the minus 2 goes as well. And when you cube minus 2, you get minus 2 times minus 2 times minus 2, which is negative 8. And then, of course, you've got x cubed. Now, most people do not leave a negative in the denominator of a fraction. It's not good form. So you can either put the minus sign out in front of the fraction, or you can put it in the numerator. Technically, it's not wrong to leave it in the denominator, but it's sort of bad form. So I would either write the negative sign out front of the entire fraction, or you could put the negative sign up into the numerator along with the 1 and make it minus 1. E, you've got 4 times the quantity x plus 2 raised to the negative 5. Again, only the x plus 2 is affected by the exponent negative 5. So the 4 just sits there. So when you push the expression with the negative 5 exponent down to the denominator to make it positive, the 4 doesn't move. So you get 4 over the quantity x plus 2 to the 5th. F has an example of an expression with a negative exponent in the denominator. Most of the problems we've done, we've been pushing them down to make them positive, but it goes the other way too. If you've got a negative exponent in a denominator, when you push it up, it becomes positive. So you get 4 times the quantity x plus 2 raised to the 5th. Again, if you see for yourself that you're having trouble with this, taking you an extra long time, this is something you need to attack before you get deep into your calculus. Third one, write the following expressions without negative exponents. So if a problem already has negative exponents in it, based on what we've been talking about, this actually should be pretty simple. You've got the factor with the negative exponent up top needs to be moved down. You've got a factor with the negative exponent in the denominator that needs to be moved up. So essentially you just switch them. The y to the minus 3 goes up and becomes a y to the third. The x to the minus 2 goes down and becomes x squared. A slightly more complicated expression, but the idea is simple. the factor with a negative exponent goes down from the numerator to the denominator, and down bottom, the negative exponent gets pushed up. And so you end up with the x minus y raised to the third power up top, and the x plus y to the second power down bottom. So again, you're just switching from top to bottom to change the sign of the exponents. How about this one? Well, in the denominator, you've already got a positive exponent, so you don't need to do anything with that. But the 2 to the minus 2 needs to be pushed down to make it 2 to the positive 2. And of course, 2 to the positive 2, 2 squared is 4. And so you end up with the fraction 1 over the quantity 4 times the quantity 3x minus 5 to the third. Pay attention to these little things because they'll cause you problems. The calculus may be trivial. You get stuck in the algebra, but you still miss the problem. Same idea here. This time the negative exponent is in the denominator. You push it up. Of course, the 2 squared you don't need to do anything to it. 2 squared is just 4, and you get 4 times the quantity 3x minus 5 to the third. This one, very similar to these others. The 4 is not part of the base that's raised to the negative 5 power, so the 4 doesn't move. So you push down the factor x plus 2 to the negative 5, making it x plus 2 to the 5, and you get 4 over the quantity x plus 2 to the fifth. Same idea here. The 4 stays where it is. The denominator has the negative exponent, so you push it up and make it a positive exponent. Again, practice makes perfect. If you feel uncomfortable with any of this, you need to attack it now, get it under control, meet with me, go to a help session, stay after class, get some help. Don't let it just linger. This problem needs to be attacked early on, and you will not regret it later. 4. Use negative exponents to write these expressions in the form a times x to the n. In other words, in the form of a number times x to a power. So the first one is just 1 over x. Well, we've talked about the fact that x to the negative 1 is 1 over x. So if you want to put a negative exponent in the problem, then you do the opposite. If you take 1 over x, it becomes x to the negative 1. Thinking backwards, x to the negative 1 means the negative sign means to push the x down. So if it's already positive and you push it up, it changes the understood 1 here to a negative 1. So if you take a positive 1 exponent and push it up, it becomes a negative exponent. Same here. 1 over x cubed is x to the minus 3. You push up a factor with a positive exponent, it becomes a factor with a negative exponent. Here, again, be careful. The cube only goes with the x. The 2 just sits there. So if you want to put a negative exponent in this problem, only the x moves, and it becomes x to the minus 3. The 2 stays where it is, so that's where the 1/2 comes from. Now you could also write that and just write it as x to the minus 3 over 2. That would be correct as well, but this is the form that you're going to find is most useful in doing calculus problems. So even though this is correct, you're going to find this form of the answer is more useful, and that's why I said to write it with the constant out front. This is a correct form, but you'll find that if you write it this way for calculus purposes, your answer is going to be more useful to you. Okay, this time the 2 is part of the base with an exponent, so now the 2 goes up as well, and so it becomes 2x quantity raised to the negative 3. Notice the difference between C and D. Now, of course, it's still not quite in the form a times x to the n. So if you want to use your algebraic properties, if you have a product raised to a power, it's the same as each factor raised to that power. So that's the same as 2 to the negative 3 times x to the negative 3. And what is 2 to the negative 3? Well, that's 1 over 2 to the third. And 2 to the third is 2 times 2 times 2, which is 8. So in perfectly simplified form, you would have 1/8 times the quantity x to the negative 3. How about this one? Again, the cube only goes with the x. The 3 stays where it is, so when you push up the x to the third, it becomes x to the minus 3. And again, you could put the -3 in the numerator just like I did with this one, but for our purposes, it's better to leave it like that. That's the form that's more helpful for calculus purposes. So here, the 3 and the x in the denominator are all part of the base that's raised to the third, so you would push the 3 and the x up and make that a power of -3, and then simplify it a bit. 3 to the -3, x to the -3. 3 to the -3, of course, is 1 over 3 cubed. 3 cubed is 27, so you get 1 over 27, so you end up with 2 times 1/27 x to the -3, and 2 times 1/27, of course, is 2/27. And now you've got it in that form, ax to the n. Write these radicals as fractional exponents. Remember, a fractional exponent is defined like this. The square root of x is defined to be x to the 1/2, and if it helps, you can think of that index as having an understood 2 there. You typically don't write the index in on a square root, but if it's helpful, you can. And as a matter of fact, you can even think of that as an understood 1 exponent. So the square root of x is x to the 1/2 by definition. Similarly, the fifth root of x, and again, if it helps you, you can think of that as x to the power of 1, is defined to be x to the 1/5. In general, the nth root of x is x to the 1 over n. That's just the definition of a fractional exponent. What about this? The square root of the quantity x plus 1 all raised to the 7th. Again, if it helps you to think of that index as being visible, that's a square root, so that would be x plus 1 quantity raised to the 7/2 power. If it's a cube root instead of a square root, it would be a 7/3 power. How about this one? 1 over the square root of the quantity x plus 1 to the 7th. It's the reciprocal of the answer in part C, actually. We know, again, if you think of that as an understood 2, it would be x plus 1 quantity to the 7/2 in the denominator, 1 over that. If you wanted to get rid of the fraction, you could make a negative exponent pop in and even write it as x plus 1 quantity to the negative 7/2. For a lot of calculus purposes, this is going to be the best way to write it. The instructions didn't say to write it that way. Either of those answers is correct as stated, but for purposes of what we're going to be doing in calculus, a lot of times you'll find this second way is the preferred way of writing it. And how about this one? Same as e, except there's a 5 where there's a 1. So obviously the translation into fractional exponents is going to be the same. That's going to be a 7/2 power. It's in the denominator. You could leave it like that as far as the directions go, but for calculus purposes, you're going to find that if you take that 7/2 power in the denominator and push it up, this is going to be the way that will be most helpful for you to write it for purposes of calculus in this course. Again, if you feel any weak areas, any hesitation in how to do these, you need to address these issues now, not let them just carry on into the semester. Here we're asked to write these expressions using radicals. First one is x to the 1/2. Obviously, it's just reversing what we did in the previous problem, so that would be the square root of x. X to the minus 1/2 would be 1 over x to the positive 1/2, which would be 1 over the square root of x. The next one is the quantity x plus 1 to the 2/3. The denominator is the index, the numerator is the power, so that would be the cube root of the x plus 1 squared. As we talked about before, you can either do the squaring first and then do the index, or you can write it where the cube root is taken first and then you do the power of 2. Either answer is mathematically the same. It just depends on what you're doing with it as to which is probably better in any particular problem. So either answer is correct there. This time we're doing x plus 1 quantity to the 7/3. This time it would be the cube root of the quantity to the 7th. And again, you can raise the 7th power first and then take the cube root, or you can take the cube root first and then the 7th power. Either is correct. Here, you've got to be careful that the 2 is not part of the exponential expression, so the 2 doesn't move. So to get rid of that negative exponent, you want to drop the base into the denominator, make it a positive 7/3, but the 2 is not part of that, so it stays. And then to change it to a radical, you've got to remember 7/3 means a cube root to the 7th. You can either take the power first and then the root, or you can take the root first and then the power. Either is correct. And finally, this is very much like the last one, but this time the 2 is part of the base that's raised to the negative 7/3 power. So this time, when you convert it to a positive exponent, making it 7/3, this time the 2 moves because it's part of the base this time. And then, of course, as we said before, 7/3 is a cube root to the 7th. You can either take the power first and then the root, or you can take the root first and then the power. Either is acceptable. If you're having any difficulties, any hesitations in getting these correct and understanding what's going on, then you need to address those problems now, not let it drag on into test time and missing problems on homework assignments and getting your focus taken away from the calculus you'll be learning. It doesn't need to be on this algebra. So address this early if you're having difficulties. How about this? Rewrite the expression using fractional exponents and simplify. So this time we've got an expression with a radical in it, but you've also got 2 factors involving some sort of x in it. So the trick here when you have something like this is to think of the cube root of x as a fractional exponent. So my first thought is to think, well, why don't I change the cube root to a 1/3 power? Now you can sort of see what happens. If you think of x as being x to the 1, you've got a property of exponents that says when you multiply with like bases, you add the exponents. And of course, since 1 is just 3/3, you're really adding 3/3 to 1/3, and you end up with an exponent of 4/3. So we've simplified it, and we've also used fractional exponents in our answer. And this is a form that you'll see a lot when you're doing calculus on an expression. Getting something in this form is very useful. Practice makes perfect. How about this? Multiply and simplify. Just goes back to basic pre-algebra, algebra 1, a product of 2 binomials. Some people call that the FOIL method. First, outer, inner, last. You multiply every term in the first factor times every term in the second factor. So you've got 2x squared times x, which is 2x squared. You've got the outer product, which is minus 1 times 2x is minus 2x. The inner product is 1 times x is x. And the last 2, the 1 times the minus 1 is minus 1. Every term in the first factor gets multiplied by every term in the second factor. You need to be good at this. It shouldn't be something that takes you even a minute to do. And of course, these 2 middle terms are like, so you can simplify that. Again, this should be second nature to you. You shouldn't be spending 2 and 3 minutes doing something like this. This should be something that you've practiced enough that you see it, you do it, you get it out of the way, and then focus on the calculus. Square and simplify this expression, the quantity 2x plus 1 squared. So there are 2 ways to do it. The simplest way is just to remember the formula that you've seen. When you square a binomial, you get the first term squared, you get the second term squared, and in the middle you get twice the product of the 2 terms. If there happens to be a minus sign here instead of a plus sign, the only difference in the formula is that that plus sign changes to a minus sign. But I won't even write it down here because we're not going to need it. But just remember that formula also exists. So if you just use the formula, the 2x is like the a, the 1 is like the b. Everywhere there's an a, you put in the quantity 2x. Everywhere there's a b, you put in the quantity 1, and you end up with the quantity 2x squared, which is 4x squared. And then you've got 2x times 2 times 1, which is 4x, and then 1 squared is 1. That's the simplest way to do it. The alternative is just when you square something, you're just multiplying it by itself, and if you do that, you use the FOIL method and you multiply it out first, outer, inner, last, and you'll get exactly the same result. If you just remember the squaring formula, life is better. Here it says to factor and simplify. You've got a fractional expression. The numerator is about as simple as you can write it. The denominator, however, is a quadratic, and it turns out that that quadratic will factor. Now, if your factoring skills aren't the best in the world, then you need to practice. We're not going to do a factoring course here, but if it's something that you're having trouble with, then you need to deal with it. Now, you can kind of check that you got it right by reversing FOIL, and you see 2x times x is 2x squared, and then if you do the outer, you get a minus 2x, and the inner is a plus 1x, and a minus 2x plus 1x is a minus x, and then a minus 1 and a plus 1 multiplied together gives you the minus 1. So once you write down your proposed factorization, you can go back and FOIL it to make sure you got it right. But in any case, that's the correct expression, and what you notice is you've got a 2x plus 1 factor in the numerator. You've also got a 2x plus 1 factor in the denominator, which will cancel, and you'll end up with the simplified quantity 1 over x minus 1. This is something that you'll deal with during this course, and the sooner you deal with any deficiencies you have, here we're talking about simple factoring, the better off you'll be throughout the entire course. Dealing with function notation, here it says f of x is 4x minus 3. You want to find f of the quantity x minus 2 and simplify the result. Now what you have to remember is when you're saying f of something, that means whatever is in here, you replace that quantity with the x in the original function. So this original function had an x here. You replace it with this x minus 2. It had an x right here. You replace it with an x minus 2. And those are the only two x's in the original function. And now it's just a matter of simplifying. And of course you simplify by multiplying this out the parentheses. And you end up with 4x minus 8 minus 3, which is 4x minus 11. Again, this is a skill that if you can just go ahead and do it without struggling with it, it will allow you later on to focus on the calculus in the course and not having to always go back and struggle with the basic algebra. Here's another example. This time we're squaring a binomial with a minus sign in the middle. Remember I mentioned that in the earlier problem that the formula we had, there was only one change in sign if it was a minus. So the way I would deal with this formula, I would realize that when I need to simplify this binomial squared and there's a minus sign, then my formula is to square the first one, square the second one, and you got twice the product of the factors, but there's a negative sign in the middle. Need to learn those two formulas. It makes life a lot easier. You could just multiply them out times each other. It's a lot easier just to know the formula. I wouldn't recommend the multiplying out way, but you can do it. The other thing that gets people in trouble is a minus sign here. You need parentheses. I used brackets just for emphasis, but you need brackets or parentheses around the expression that you squared out, because that minus sign carries inside and changes the sign of every term that you just squared out. Don't try to do it in your head. Take the extra step, write it out, put your parentheses in. You're much less likely to make a sign mistake. So when you distribute those minus signs, the x squared becomes a minus x squared, the minus 2x squared becomes a positive, the minus 2xy becomes a positive 2xy, and the plus y squared becomes a minus y squared. And then of course you notice you have like terms. You've got a 3xy and a 2xy, which is 5xy. So the final answer would be 5xy minus x squared minus y squared. Factor out common factors and simplify. You will occasionally come across a problem where when you do the algebra, you get an expression that looks maybe something like this, and the simplest way to deal with it is to factor out common factors. So what you notice is you have a plus sign right here, and you've got a term over here, and you've got a term over here. So you've got two things connected by a plus sign. So the idea of factoring is within the two terms, look for common factors. So in the left term, I notice I have an 18, and in the right term, I notice I have an 18. So in the end, I'm going to be able to factor out an 18. I also notice that there is an x squared plus 2x in both terms, but one of them is to the second power and one's to the first power. You can only factor out what's in both, so there's a first power in both. So when all is said and done, you're going to end up factoring out some common factor and being left with what didn't get factored out. So if you look at this plus sign divides this thing into two terms, and you're going to pull out some common factors over here and see what's left inside. Now, we've already said there's an 18 that's going to come out of both of them. And we also said that there's an x squared plus 2x that can come out of both. Notice there's an x squared plus 2x quantity squared in the left one, but there's only a first power in the one on the right, so you can only bring out what's in both. So there's only one in both. So that's your common factor. Now the question is, what is left? Well, what is left over here? Well, the 18 came out, and one of these x squared plus 2x's came out. That means you're left with the one that didn't come out. And then you move to the other side of the plus sign, and you'll notice that the 18 came out and the x squared plus 2x came out. So what you're left with is what didn't come out, and that is that 2x plus 2 quantity squared. Now, if you're struggling with that, deal with it now, because you're going to see some of these later in the calculus course, and if you're struggling with them in the middle of trying to deal with the calculus 2, it just compounds the problem. So handle these deficiencies early on. The only thing left to do now is to square this and simplify it, and we just had the formula for squaring a binomial, so it shouldn't be any big deal now. You square the first term, you square the second term, and then you double the product of the two. Well, 2x times 2 is 4x. You double it, you get 8x. You can always square it out by multiplying it by itself by hand, but I don't recommend that. And then just collect like terms. You've got a 4x squared and a 1x squared. That's going to make 5x squared. You've got a 2x and an 8x, which is going to make 10x. And so when all is said and done, you're going to have 18 times the quantity x squared plus 2x times the quantity 5x squared plus 10x plus 4. You need these skills occasionally as you move through the calculus course, and the better you get a grip on it now, the more you'll be happy with your grade in the end. And last but not least, how about rationalizing numerator? At some point in your algebra career, you were rationalizing numerators and denominators. They're asking you to rationalize this numerator, and there's a trick. The trick is to multiply the top and bottom by the conjugate, and since we're rationalizing the numerator, it's the conjugate of the top, which is the numerator. What is the conjugate? The conjugate is what you get by changing the middle sign. So if it's a minus, you change it to a plus. If it's a plus, you change it to a minus. And you multiply the top and the bottom. So I changed that minus to a plus, and I multiplied the top and the bottom of the fraction by it. So I'll take the product in the numerator and the product in the denominator and see what happens. We're trying to rationalize the numerator, so you don't really even have to multiply out the product in the denominator. You really can focus your attention on the numerator. And remember, you're going to use the FOIL method. First, outer, inner, last. You're going to take the first one times the first one, the outer and the inner add together, and then the last multiply together. So what you've got is the square root of x plus 1 times the square root of x plus 1. So you get the square root of x plus 1 squared. And then you've got, on the outer term, you've got a 4 times the radical, which is 4 times the square root of x plus 1, and then on the inner you've got minus 4 times the square root of x plus 1, and then on the end you've got minus 4 times 4, which is 16. Now this is why the rationalization works. The outer and inner term, if you do it properly, are going to always cancel each other out, and you're only left with the square of the first term minus the square of the second term, and that's going to be radical free, and that was what you're trying to do. So when you square a square root, it just pops the square root off, so you end up with x plus 1, and then you've got that minus 16 on the end. Like I said, in the denominator, you don't really have to multiply out the denominators. You're really focusing on the numerators. You just write them down. This times this. You don't actually do the multiplication. And you'll see why in a minute, because up top you've got 1 minus 16, which is minus 15. And you can see now why you didn't want to multiply it out, because that'll actually cancel. And you end up with 1 over the quantity square root of x plus 1 plus 4. And now you have done what they asked, which is rationalizing the numerator and simplifying. Like I said, this is not the entire breadth of everything you might need to know algebra-wise, but it's a sampling, especially for early test material. Take it seriously, get help now, Don't wait. You've got plenty of assistance. You can come by my office during office hours. You can go to the tutorial assistance at the MTLC. I highly recommend that. There are just all sorts of hours you can use. And there's time at the end of most lectures where you are encouraged to stay and start your homework and ask questions then. And typically every semester there's also some help outside of the math department by the tutorial services provided by the university in general. Haven't seen those yet, but when I get that information, I'll share that as well. Last thing is, again, to encourage you to do this now. If you wait till later to deal with these issues after you've already had a bad test grade or two, you've already harmed your test grades by then, which it harms your course grade by then, and sometimes you've simply waited too late to get the grade that you want to get in this course. So please tackle this early and get the help, and you're going to thank yourself for doing that later.